shrink. Oh, someone else joined. Please sound. Okay. So, this week is all about classes, but like with an additional little bit of dynamic memory in classes. So I think we might have talked about it. We might not have talked about last time classes. Might have just talked about pointers and stuff. I think it was just pointers. But now it's pointers plus classes, and that adds a whole new dimensionality. And in my experience, when you're learning about it, really, it just seems like it makes everything really painful. Okay, here we go. So this week all you gotta do, just the quiz. It'll be the quiz. I think you guys get like the weekend to do it, so do it this weekend. I should have put the date there, so for myself, but that's fine. Next week lab is gonna be a big one. Basically, you can think about it. You used vectors before. You're not creating you're not creating like a vector class all of itself, but you are creating something that's like a vector with the functionality of adding. So if you think of a vector as like a column of stuff, you can put stuff on top of the column and you can take stuff off. So a vector that can do that. And then for it's two things. And so then the other one, you can think of it like a line, and you can add stuff to the end of the line or take stuff from the front. So it's called a stack and a queue. That'll be next week. And it uses pointers with dynamic memory. And so you'll have to create all the stuff we talk about. You'll have to use all these concepts. But then you'll also, next week, we'll talk about templates, and templates allow you to create a class that can store any type of data type. And that's really good for storage data types, because then you don't have to specify what is going to be stored in whatever object you're making. So combining this with that creates what the next lab is going to be. So this is all really important. To start off, we're going to talk about the big three. The big three are the copy constructor, the copy assignment operator, and the destructor. Do you know how long we get for next week's lab? Probably just the same amount of time. It's big, but I mean, you still just get a week. It's definitely doable. You'll be fine, Gabby. Let's see. Yeah, the big three are the copy constructor, copy assignment operator, and destructor. All what they're useful for is because pointers exist as a concept. If pointers didn't exist, you wouldn't need those things, but they do. So the issue with pointers comes around where if you decided to do, like, let's say int x equals 2 without pointers, you could just do int y equals x. And now if you did x plus plus x and minus minus y, and then couted x space y. So if we ran this, let me make this. Oh, I need a semicolon. Semicolon. Oh, I need to include all my shit. Always gotta do it at the beginning of projects. Always so fun. And there we go. So with all that, without pointers, you can just change x and y. Oh, it ain't happy for some reason. Cout. Oh, running the wrong one. Set as startup project. There we go. So with this, you can change x without changing y. However, if you made them pointers, and so instead of saying just 2, you have to say new int 2, like that. Instead of doing numbers, if you do pointers like this, and it wouldn't even matter if you're using heap stuff. So you could do like int var equals 2, and say address of var. And so all this is on the stack, but it's still pointers. If you did dereference x, so changing what x is pointing to, and changing what y is pointing to, now they'll be the same thing. Oh shit, gotta dereference them here. Now, since they're pointing to the same thing, that value is the same across both of them. So anything you do here to one of them happens to the other. That's the really important concept, and you can see it just with super basic pointers that are pointing to one thing of memory right here. Now, most of the time when we talk about it in the form of arrays. So with an array, don't have it set up like that, but you can do new int, let's say like 3, and then still saying that's x. And then now here, if we say for int I equals 0, I is less than 3, plus I, x, I equals I times 2. So just some random thing in there. And so now if we print out x1 and y1, they're the same thing. So most of the time, this is where we're talking about it. Because this gets a little harder. Oh, let's do 2, so it's 4. This gets a little harder to fix the problem for, because before, instead of doing new int x, so we did like this. So with this, instead of doing x, the really easy solution, so I guess I should have talked about the solution before. Sorry about that. But the solution to this is saying new int star x. So here, this is saying allocate new memory on the heap for this that stores a value 3. And here it's saying allocate memory on the heap, and at that address, store what x is pointing to storing. So like this concept is how you copy x through a deep copy instead of a shallow copy. And so that gets new terminology, the deep copy versus shallow copy. Shallow copy is just copying the memory address. Well, actually, shallow copy is doing just assigning one variable to another. That's what shallow copy is, because when we get to classes, a shallow copy would be just member variable assigning one to the other. But you don't want to do that because you don't want to assign those addresses. Member pointers are just addresses. That's just a variable that stores an address. And so this way you're copying the address, but you don't want to do that. You want to copy what's at the address. And so that's why this is the easy solution for that. Now, when it comes to arrays, like pointers with multiple pieces of memory, it gets a little harder. So for one, you have to know how long this is. And C++ doesn't have something that keeps track of that for you. There's not like an x dot length, because x is just an address. It doesn't know that. So you'll have to keep track of that array length. So you could do like array length equals 3. So then here's array length. And then here's also array length. So you have to do that. And then if x is this, you'll have to do the same thing. And instead of here, we'll do array length. Here, you'll have to do int I equals 0. I is less than array length plus I. And then you do y I equals x I. And so this is how you get into that deep copy territory. And so here you're not copying addresses, because when you do the brackets I, you're no longer dealing with the memory address, you're dealing with what's stored there. And so that's copying everything over. So then if you do plus x2 plus y2, wrong brackets, minus, so you can see the difference. There. So you do that. See, x is now 5, y is 3. Ooh, yes, Gabby, that's actually a great point. So before we talked about how like with objects to do x dot something, whatever, like to do a variable dot, but with pointers you do this. So if we did like x dot funct, For pointers, it would be this, and that equals star x dot funct. You can think of this, these square brackets, what they actually are doing is x plus 2 dereference. There we go. You're mad about, there it goes. So that's actually what it's doing right here. See, that's a great question. So if we replaced that and ran it, that would be what we're trying to go for. Because these square brackets are just shorthand for adding 2 to the memory address and then dereferencing it. And that also shows how like 0 is the first memory address when you're indexing. It's because it's adding 0 and dereferencing that. So yes, the brackets basically do just dereference the pointer, but they add a certain thing. So you could, when you're doing a normal dereference, like if you did int star z equals new int 10, you could do z0 to get access to that element. So showing all the ways that yes, it is just dereferencing, but adding a certain number to the address for dereferencing, because arrays are just pointers, but there's multiple elements allocated for it. Okay, so this is just a non-class-based discussion about like how shallow versus deep copies work in relationship to pointers and stuff. So now when we get into classes, you'll see how it's just a little bit harder to deal with this. Like this, when you're not working with classes, this is a really easy concept to handle. Well, easy might be the wrong word, but it's really straightforward and like you can easily show it off like this. But classes become a little harder because you're not supposed to just like go into a class and get the variable and do this. You have to create functions that do that. And so the functions that do that are the big 3. So now we've covered that, let's actually jump into the study guide. So yeah, what are the big 3? Let's create. I need this bigger. Let's create a class. C++ class. We're gonna call it, I'm not gonna use I hate vehicle. I friggin' hate, we talk about vehicles so much. I talk about vehicles so much. I'm gonna call the class friggin' Steam. Sure, I see the Steam logo on my computer. Steam, do not HTTP, cool. Okay, so you know your default constructor. You got that. And here we're gonna put this in public. You know your default constructor. You know one with parameters, so let's say int x. Now we have the copy constructor. To copy. I did that wrong. Did it? No, that's for the assignment operator. Why is that mad? I did something wrong. That. There we go. I promise you I can code. It's somewhere in my brain. Okay, so this is the copy constructor. This is the, and so that's all a constructor we're going to worry about. The next thing is not a constructor, it's the assignment operator. So the assignment operator is operator equals Steam address to copy. There we go. And then the destructor is this. Ooh, yes. One last thing for the destructor. Here, it's really easy. At the very end of our program, we would just do, so okay, Z wasn't made with square brackets, so it's delete with brackets X, delete with brackets Y, and delete Z. So that would be how you delete those things to deallocate their memory. But again, with classes, that you can't just like call delete on the object itself, because the object itself isn't what's dynamically allocated, it's the stuff inside of it. So you can't just easily do that. But that's where the destructor comes in, because the destructor gets called when the object goes out of scope. So yeah, right here, these three things, I'll put an enter there just to separate them real quick. These are the big three. Now, when you're first writing it, maybe just to confirm that you have the big three, you can organize your code like this. You could say like big three. And so that like make sure that you have the big three. But personally, I am at a point where they're definitely still the big three. Like I understand that concept, but I think of the big three about like what they are. So this is the copy constructor, so I keep it with my constructors. This is an assignment operator, so I keep it with operator overloaders. And then the destructor is usually like its own thing. There's not really a concept for the destructor is a really unique concept. So all these things we have right now, I don't have any dynamic memory in here. So this is all still valid without dynamic memory. You could do these things without that. Because all they do, oh, stop it. All they do is just redefine the behavior of these functions. So obviously you have to create your own constructors, like the default and the one with parameters. But the copy constructor is kind of like the default, where it does exist without you doing this. Like there would be a copy constructor. The only issue is that the copy constructor would do a member by member copy. So let me just there we go. That's all done now. So the copy constructor by default would just do a member by member copy, and that can cause issues where it's just copying the memory address. So that's why we redefine it here. But if for some reason you were creating an object that didn't use pointers and you wanted to define the copy constructors to be different than just member by member copy, you could change that. Same thing with the assignment operator. Usually the copy constructor and the assignment operator do the same thing. So they're very similar. It's just this has that return. So you have to keep track of that. And then in this case, this keyword, the invoking object might already have some values. So you'll have to deal with those first before you actually copy stuff over. So yeah, the functionality of these two is usually very similar, but again, they don't have to be. C++ is allowing you to do whatever you want so that you could have them do different things. And then the destructor, if you don't define the destructor, it doesn't do anything. It's still called, because the destructor is always called when an object goes out of scope, but it doesn't do anything. And so here we're saying we want to do something when an object goes out of scope. So a really straightforward one here, we can just get all our includes in there. And actually, no, it's fine. So here in this destructor, cout, Steam has ended. So you can see that. Here we're going to do cout. Steam has copied. And it does have to return something. So I'm going to return, let's just say Steam, just a defaultly constructed Steam object. That's fine, right? Is that not fine? That's still not fine. Well, it's a little mad at me. What am I doing wrong? Don't at me. Why are you mad? No, that should be fine. I'll deal with that in a second. That's fine. That should be fine. Sure, that's not going to give me any errors. Probably not. Probably not. Okay, and then cout Steam copy has copied. Oh, this is assigned. Okay, so all these things, obviously, they're not actually doing anything. Maybe not obviously, but they're not actually doing anything. But they are printing out a little statement here. So now if we go to our main, and we're going to delete all this. Right here, we're going to hashtag include Steam. And we're going to create some Steam objects. Just going to call it A equals Steam. Oh, that's mad. It says no suitable copy constructor. Did I write the copy constructor wrong? There's like a 10 out of 10 chance that I wrote this copy constructor wrong. Const. I'm a butt. I always forget. I hate const. It's great. Const is really okay. There we go. There we go. Steam. There we go. Okay, that's what I wanted. Oh, it's still a little mad. Yes, because this isn't valid anymore because this is const. There we go. So that's the copy constructor. Very sorry about that. Didn't write that correctly. Goes to show that just because it compiles does not mean it's correct. There we go. So Steam A equals Steam. We're going to say Steam B equals Steam. And Steam C equals A. So here, we're just going to do that. One. In here, for good measure, we'll put little cout default. And I know this is a lot of dumb work. I know this seems super redundant, but I really just want to show you like how everything's connecting. And just when it gets called. Okay, so we got that. So we got here, 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 and then we're going to do A equals B. There we go. So now we're using everything, I think. Oh, so we got that, we copied, we assigned, and everything's going to be destructed. Okay, cool. Running this, let's look at the order that everything's printed out. So we got default right there. So default is saying Steam A. This int is the int right there. Then here, Steam has copied right there. This default, I think, is from the copy. Not from, it's from the assignment operator. Okay, so yeah, right here, this assignment operator. I'm going to turn that off. So yeah, this assignment operator, A equals B right there, that created a default. So that's what that was. And then Steam has been assigned. And then to return. And so this first Steam is ended is actually the to return going out of scope. So even though we returned it, the object to return itself goes out of scope. So that's that first one. And then the other three are A, B, and C going out of scope. So just showing you that concept right there, you'll see that Steam has ended, just happens at the very end of everything. I think if we had done one more, D equals Steam. So I just want to see because it's not Steam has ended. There should be a middle Steam has ended. Yeah, there we go. So that Steam has ended was that to return in the middle. And so whenever an object goes out of scope, that's when Steam has ended shows up. That's when the destructor gets called. So does everyone understand like when those get called, the difference between the copy constructor and the assignment operator? Like, so we'll get into using like pointers in a second, but just getting that out of the way. Cool, cool, cool. Okay, so now let's add pointers into the mix. So this is gonna get a little wonky. Int star x equals, oh, there we go, just int star x, sure. Okay, so with that, we now have this x variable. And we're gonna say the default does x equals new int 10. Oh, that was bad naming choice. Call it PTR. I am just the king of bad choices. Okay, so PTR, and then here we're gonna say PTR equals new int x. And so here we're gonna say, just to start off, we're gonna say this x equals to copy dot point, oh, it's not x, it's pointer, it might be. So there we go. And then here, we're gonna say this PTR equals to copy PTR. Oh, someone didn't want to be here. Dot pointer. And we still have to return, we're gonna return this object. Star this, there we go, dereference, there we go. And then here, we're gonna say nothing. We're not gonna have anything happen. Yeah, because this, I'm showing bad code right now. Spoiler alert, this is bad code. So let's actually make this public so we can mess around with it. Yeah, let's make this public for now. Usually that'd be private, but for now we're gonna make it public. Okay. New int 10, oh, new int, I don't want a constructor. There we go, I want an actual value. There we go. Okay, so in this case, we did 1. Let's, instead of doing 1, let's do 3. So we got that all set up, and these are pointers. So the only new ones created were here. So we do C, A equals A, that'll set that equal to that, and then A equals B, that'll set that equal to that. Okay, I don't need D anymore. Okay, so what we're gonna do here is, first off, right here, we're gonna say C dot pointer equals dereference C dot pointer equals 30. And then C out A after changing C. Dereference A dot pointer. I probably spent way too long on this, I realize. I think, oh no, only like 40 minutes. Yeah, this is fine. This is good. We're still good. Okay, so that right there, that change, we're gonna see that how that affects A itself, even though we only changed C's. And then here, we're gonna print out A again. To B star A dot pointer. And we're basically just gonna do this again. but here, A after changing B. And we're gonna make that 55 and B. So we've never changed A. Well, I guess we changed A there. We did change it there. But we're just gonna see what this does. And if I'm correct, oh, I didn't put spaces, so it's a little weird. But yeah, so here's where the issue comes in. You can see we got that C is equal to 30. We changed C to 30, but that changed to A. We changed that, and that's fine, because when we printed out A, it was 3. However, when we changed B, that also changed A, and we don't want that to happen. We want A to be its own independent thing when we do the assignment operator. So all this comes down to when we assign one object to another, we want them to be their own independent things. We don't want changing one to change the other. So now to make everything right, let's go in here, and now here's where we affect the big 3. So in the big 3, here, instead of doing this pointer equals to copy pointer, well, first, since it's the copy constructor, so we don't need to do that, so we'll just say this pointer equals new int dereference to copy pointer. So we did that before, so easy right there. That's a good one. Here, assignment operator, since this object could have already been initialized, we need to delete this PTR. And technically, this keyword is implicit. It's implicit in all this stuff. I don't think I have any duplicate keywords, so you could just get rid of it. But I like to have it just to be explicit. So first, you have to delete it, and then you have to do new, same thing as before, int dereference. So there you go. This is very similar to this, just you have to delete any existing pointers to get rid of them and then reassign them. And we'll get to the destructor later. So now here we go. Now if we run the same exact code, those changes didn't occur. So you can see we changed C. A after changing C, still 10. The default's 10. A after assigning to B, 3, that was the same as before, so that when we assigned it, it definitely kept that 3 value because it was assigning it to the address, and so now before it was pointing to the same thing as B was, which was 3. But here, once we change B, that does not change A. So it's super simple, just a couple lines of code, but it really affects how your program works. Finally, the whole the destructor, that comes in for a different issue, which we'll see when I create the thing for it here. I think we've done this before. I think you guys are definitely, I like doing this one. We can just put in a for loop. So if that's good for everyone, I'm gonna get rid of it. No one has any questions? Dope. So if we make a for loop, int I equals 0, let's make it long. Long I equals 0. I is less than long max plus I. We're gonna do steam var equals steam. So here we go, right here, no pointers that you can see. Obviously we know there is pointers just in the back end, but no pointers you can see. So we got that and we run it. Look at that, my memory, it's spiking. What the fuck? Why? And it's gonna crash in a second. I was hoping that it would crash sooner, but that's fine. It's gonna crash. But we didn't use any pointers. Well, inside of a Steam object, it is using pointers. And this Steam object inside this loop is going in and out of scope, just back and forth, just in scope, out of scope, in scope through this into loop that I'm looping a shit ton of times. I don't know how big long max is, but it's a lot. And so to deal with that, we use the destructor, because the destructor is only called when an object goes out of scope. And when an object goes out of scope, you can't use it anymore. And so we're assuming that you also can't use anything that it has pointers pointing to stuff for. So in that vein, in here, we have to delete this dash pointer. So if we do that, and we're using delete without brackets, because we're not using brackets, if we do that, now it's totally fine. Now we're back to normal, good, fun, having a great time. So that's what this destructor is for. And so the copy constructor, assignment operator, destructor, they all work together to get the cohesive experience of using pointers properly if you set them up properly. Again, we had them before. We had written a copy constructor, assignment operator, destructor, but we didn't implement them properly, so they didn't do things properly. So just having them isn't the cure to pointers. You need to actually use them properly. Okay, so this is with just single things. The last thing I want to talk about is if you have arrays. So we're going to do the same thing with arrays, and we're not going to talk about the values stored in them because we just talked about values with like single pointers. So I don't want to have to assign stuff to these arrays. But let's go into how we do this. So copy constructor. When we said this pointer equals a new, we can't do this. We can't do that anymore. It's not just a simple that. What this would do is go to the first address of the to copy pointer, and whatever int is stored there, assign it to here. So if it wasn't an int pointer, but let's say, frick me, what are we doing here? Hashtag include string. Because again, you can have pointers to anything. So hashtag include string, and make this a string pointer. Dope. Still want int there because everything else is going to be the same because we're using this with that for size. Is that not an error anymore? Oh, still great. Cool. Glad. I was hoping that'd be an error. It's not, but either way, this would be bad. So what you have to do is copy over the size. So we don't want that first thing. We need to get the size. So it's the to copy pointer size. Well, how do we get that? There's no way to do it with just to copy. You can't do to copy dot length. Not a thing. So instead, we have to add a new variable that's int array length. And so here we say array length equals to 10. Here we did array length is equal to x. And so here we would do this pointer equals to copy dot array length. Why is that not happy? There it goes. Yeah, okay, cool. So there we go. It's the to copy dot array length. And so it's setting this pointer equal to a new array, and it's that length. And it's just a simple, again, I keep saying simple, because to me it's simple, but it's not simple to you guys. So if I say something simple and it's not, please ask questions. Don't think me using simple means that you shouldn't ask questions about it and that you're dumb for not getting it. You're not dumb. Just for me, in my head, it's simple now, and I'm very sorry if it's not for you, and I'll happily answer any questions. But so yeah, I is less than to, and actually you also have to do this array length equals to copy dot array length. So you have to do that as well. So as long as you're doing someone's array length, this array, because they should be the same thing now. Plus I. Question, every time you need the array length, you make a new variable? So yes, if you have multiple arrays inside of your object, yes, you would need a new variable for that. And that's why vectors are really great because they keep track of that for you. That's why for the next lab, you will have to use an array, but there'll just be one array in your object. So you just have to have the one variable keep track of that. But that's why when you're just doing regular old shenanigans, it's a really good idea just to use a vector because it keeps track of that information for you. But yes, every time you need the array length, well, every time you need the array length, you don't have to make a new variable because you just use the objects. Because whenever you create an object, and if every time we make a new Steam object, it makes a new pointer and a new array length variable for us. So we just use the ones associated with that object. You don't have to manually make one. Does that answer your question, Alyssa? I went on like a tangent there at the beginning. So yeah, yeah, okay, cool, awesome. Yeah, the object, that's why objects are so great, because they do create that stuff for you. And vectors are just objects and they keep track of all that information. So here, now we gotta say this pointer at I equals to copy dot pointer at I. So there we go. That's how you do it for that one. And then, like I said, the copy constructor and the assignment operator almost always have the same functionality if you just want them to be a basic copy. So you can just copy this over to here. However, there is that before and after stuff you need to deal with. So in this case, right here, you need to delete the original pointer, but it's not delete without brackets because now it does have brackets. So bracket delete. And then returning to this object is still standard, so that's totally fine. Anything else that I'm thinking about? No. Okay, cool. Cool, and then finally, delete with brackets there. Why do you need the this? What does it do? Okay, that was like a last week kind of thing, but that's the invoking object. This is saying get the pointer variable of the invoking object. It's technically implicit. You don't need it unless you have two variables called the same thing. If you want to go over that, if we have time at the end, you can ask that again. But also the recording for last lecture, we covered that. Last discussion, sorry, not lecture. Last discussion, we covered that, and we covered that a lot because like creating a constructor that has a member variable the same name as a parameter, that's where you'd really need to use it. Oh, okay, so yeah, it's just the implicit. So like if we did this, it'd be fine, but it's the invoking, and I'm doing it explicitly just so you can see where it's coming from. Cool. Okay, so here, this is all great and dandy for arrays. So if you run it, this is now totally fine. Nothing breaks. Oh, unless it does want to break. Pointer is an undeclared identifier. Did I change the name on accident? What did I do? Pointer. I get rid of this. It shouldn't need this. That's great. It should be implicit. Yeah, no, it's still mad. It's still very mad. So let's figure this out. Oh, new int string, not capital. String. Oh no, it's string. New int string. New string. It's probably mad about all of these. Please fix it. Oh God, what? Pointer is not a member of Steam. It's right there, pointer. Oh, this is, oh, you love it. You love to see it. This, pointer right there. Error type, why, have to include string? Error type still an error type. No, that's fine. I did something to break it, and you know you love to see it when your TA does something that I don't even fucking know. Let me Google it real quick. but string should be fine. Let's move it back to int. Let's see if changing that, and I'll figure out why string fails later. Int 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 int. There we go. Okay, so string was failing. Might be. Should have checked that. We're not printing anything else. That's fine. Okay. So now that I got that settled, so yeah, this is totally perfect for that. One last concept. I know we've talked about this a lot, but one last concept is, no, actually, I'll leave that up to you. Yeah, no, you'll figure that out when you get to it later. But yeah, so there you go. That's all the shenanigans with like copy constructors and stuff with pointers. Obviously, this isn't all the examples of it. Like I even hinted at there, I was going to do one more example, but I think we should move on to the other stuff. There is more there, but you'll figure it as you go. Just understand when they're called, and remember that pointers are just the memory address. So if you need a new one, you got to do some stuff with it. Okay, so study guide. What are the big three? Assignment operator, copy constructor, destructor. What is the rule of big three? If you have one, you should have the others, because if you ever need the copy constructor, then you probably need the assignment operator. And the times when you'll need those is when you have pointers. And if you have pointers, you should really have the destructor. So yeah, it's whenever you have one, you should have the others. When are the member of the big three called or used? We went over that with the whole like printout statements. Copy constructor is when you're constructing by a copy. Assignment operator is when you're assigning something, but it's not in construction. So not when when the object is constructed, but later when you're assigning one to another. And the destructor is when the object goes out of scope. Why must you write the members of the big three? I didn't explicitly say why, but we went over it really. Maybe I did explicitly say it at one point, but we went over that. And then what are the similarities between the copy constructor and the copy assignment operator? So like I said, if you want them to just be a deep copy, their functionality, this big part in the middle here, is almost the exact same. Well, it is the exact same, but in the assignment operator, there's the initial getting rid of whatever the pointers are pointing to first, because when it's being constructed, it's not pointing to anything. You know it's not being pointed to anything. But when it's assigning, it could already be pointing to something. So you have to deallocate that memory first. And then finally, you have to return this object, because assignment operator has to return something. And that's what finally gets assigned to the left. So that's the important part there. Cool. Okay. So any questions on the big three? If there's a question, I'll answer it. Definitely. Cool. Okay. Dynamic memory. What is a shallow copy? So we kind of also went over that. So the shallow copy is when you just do a member by member copy. So that would be saying, instead of this copy constructor here, we just did to copy dot array length. So we did actually do that. That is a shallow copy. So you don't need with non-pointers, doesn't matter. Shallow versus deep, that's nothing. And then here we would just do to copy dot pointer. So we went over that. So if you just did that, and we did this for both of these, that'd be the shallow copy. You're not making any new arrays. You're not allocating any new things. Just member to member copy. And then a deep copy is what we had before, is when it actually allocates new memory and then copies over what is in those addresses instead of just the address itself. Dangling pointers. So dangling pointers would be right here. So right here, technically, anytime you delete, so right here as well, if you delete a pointer, it becomes a dangling pointer. The way you don't have it be dangling is if you explicitly do this pointer equals null pointer. So it's no longer dangling. And same down here. So I did not go over that one. But yeah, if you delete, right after you delete, so like right on this line, if I put something there, this pointer would be dangling. But when you assign it to null pointer, it no longer is. Or when you assign to something, it no longer is. But just deleting something and then deleting a pointer and then not assigning it to anything makes it dangling. Now here, I knew, like right here, I knew I was going to assign it to this pointer right after. So it wasn't going to be dangling for very long, and there was never going to be a time where it was dangling and something could happen to it, because it's one line is deleting it, the next line is assigning it, because the spaces don't technically exist. So that is totally fine. Like when you're writing code, that's totally fine, but it's still technically there was a time when it was dangling. Right here, when it's destructed, we don't care that it's dangling because we know it's no longer going to be used because that object is going out of scope. So that's also fine for it to be dangling. When you don't want things to be dangling is when you delete it and then you don't do anything after, and now there's a chance for someone to call another function and do something to that pointer and it's still dangling. You don't want anyone to be able to do stuff to a pointer that's dangling, because that could have undefined behavior, because it's not set. If it's set to null pointer, then any error that occur would be you can't do something with null pointer, and so that's explicitly saying this is 0. But and if you assign it something else, then it's now actually usable and you could do stuff with it. But dangling is just like a weird space. So yeah, that's not unique to classes. We could have showed that off just in main really easily. Okay, so that's all that. Now we get into the const keyword, and that's a super, super fun time. I'm glad it's just a little bit there. But yeah, any questions about dynamic memory? That definitely connected with the big 3 a little bit, except for the dangling pointer. Okay, const, woohoo. So the way I like to talk about const is just with a big, long list. Okay, so we got int a equals 1. I told you this list would be back. I love this list. Const b equals 2. Without pointer, oh, it's constant. Without pointers, that's super straightforward. Let me make sure I get everything. What does a const pointer stand for? What does it mean to label a variable as constant? Why would you do that? What does it mean to return a const type? Why would you do that? What does it mean to create a const class member function? And why would you do that? Okay, so what does the const keyword stand for? It stands for constant. What does it mean to label a variable as const? So why would you want to do that? So we're going to see there's a bunch of different ways to label a variable as const, but in general, it's to make it so it can't change. So it can't change, or something about it can't be changed. That's whenever you see const, understand that something is being restricted from changing. Something is being defined as a constant. Something can't change. What it isn't always straightforward with pointers. Like you might have to think about it a little bit, but with like this stuff, it's really easy. Like here, this is saying you could do a equals 3, but you could not do b equals 4. See, it gives a little error there. You could still see out b, but you can't change it. So you can still use it, no changing though. Okay, actually, let me leave that. There you go. So that's an error right there. What does it mean to return a const type from a function, and why would you do that? So returning const protects the variable from being changed once it's returned. So if you return like const int pointer or something like that, foo return. This makes it so, well, here it's protecting the, yeah, that's, so you can, that doesn't actually do much. Yeah, but that's even angry. You can't really do that. Yeah, here we go. So, oh, what? Oh. Figure yourself out. There you go. So technically this is protecting the return type, because it's saying it has to return a const value. This is a little bit redundant since you can do a equals b. That's basically what it's doing. And so a doesn't have to be const, even if b the return type is. So it's a little redundant there, but it really shows in like pointers. And this also makes it faster. So we'll get into that in a little bit. And then, yeah, we'll get into that when we get there. So, but first off, just the basic of const. So it's 1, 2, there. Okay, so now with pointers, we know int star C equals new 3. There you go. New int 5. Get that out of the way. Const int star C D equals new int 6. Int const star BCD E equals new int 7. That's not a semicolon. Int star const BCDEF equals new int 8. Okay, so there we go. Hopefully you notice that first one isn't const at all, but then this one I slowly moved the const forward. And two of these things are the same. The two that are the same is the relationship between const and the star. We'll see how they affect it in a second. So we can do two things we can do. We can do dereference C equals 9, and then C equals new int 10. Dereference D equals 11. Can't do that. D equals new int 12. Star E equals 13. E equals new int 14. And then finally, F star F equals 15. F equals new int 16. So we got all that. And personally, this is how I remember it. So there is a pattern here, and students have said it before and they figured it out and it makes sense to them, like what it actually means. Like before star, it's not a pointer yet or something. So you can change the class, but you can't change the not pointer part. Yeah, you can change the not pointer part, not the pointer itself. But then here it's after the pointer, so it's now const. It is a pointer, and so you can't change the pointer part. And so you can't change the pointer, but you can change what it's pointing to, or something like that. But that confuses me personally. I just remember this pattern. If I need to do it, I literally just type it out. I haven't had to like answer a question about like what will this do kind of thing. You guys will have to though, so you have to remember it. Whatever way you decide to remember it, that's totally up to you. But one key thing to note is that D and E have the same issue. You can't dereference and change it, and that's both when they're both before the star. And then finally, technically, so both those are the same, so it doesn't matter where you put the const anymore, but you can do int const star const A, B, C, D, E, F, G equals new int 100. And so in this case, G can't do either of those things. So however you memorize this, that's like the difference between these two. That, in my opinion, is the hard part. This is easy because you can do both of them. This is easy because you can't do both of them. And then also the const before the star is the same thing. Const after the star is its own thing. But yeah, you just have to remember before and after the star what that means here in this context, like which one it is. Like I said, I just remember this pattern. I do left to right building it up, and then with the star C, you can change it. You can't change it, but then here you can't change that one. So like it's the first one you can't change. You would have to make sure you do this order right. I personally do, but probably do that. That's fine. So this is the effect of, this is the const without pointers, very straightforward. Oh, so this is constant variables, by the way. So there's variable const, and then there's functions with const. So this is all just variables. So this is variables without pointers. This is variables that are pointers. And so const just does a lot. Const has many effects. It's great. And if you're thinking like, why would you ever use const? It's really just it's like a check on yourself or a check on other people. So if you're the only one using the program, you would use const to make sure that you keep yourself in check. So if you know that you never want this to happen, then you can just put a const there. And so if you ever do this, then you're like, your program will tell you, hey, you can't do that. It's the same thing up here. Instance where you do this, it'd be like const pi equal, and it'd be like a float. Equals 3.14. And so here you're saying, I never want pi to change. Same context, but for pointers, if you ever have a situation like that. Obviously, this like makes more sense in the terms of in math, pi is a constant. And so that's like, that makes sense. Here, the effect of constant is harder to put into words. And so it might not seem as obvious, but just like if that functionality is something you know you don't want and you know you actually explicitly don't want it, you can make it constant. Okay, so now const in the term of functions. So I'll leave that up. So functions, there's a couple of places const can go in functions. There's the return type, which does, when it's in the return type, that's just a commentary that's the same thing as all this here. So if const is in the return type, it has the same effect as this. So I'm not going to talk about that. The other place you can see const is after the return type. There we go. And now this should be mad at me. Yes. So const right here, even though this is the right place, I promise you it's the right place, but it's mad at me because this is a non-member function. So you can't do it on non-member functions. And the reason why, we'll get to it when you see it. But here we go. Let's make a new function in here. Call it just void changer. We're gonna call it void changer const. So now if we go here, I'm gonna right click, not right click, hover over, show potential fixes, create definition. So here we go. We got this changer function. So here we go. Const can go right there. What this does, it makes it so if you ever try to say like this, array length or the pointer, doesn't matter which one you, just any variable, if you say that equals 10, that's a no-no. So right here you say expression must be a modifiable value. So what it's saying is this can't be modified. This is not a modifiable value. This const right here protects the this keyword. It makes this a read-only function. So you can only read values from the this keyword. You can't change them. If you wanted to do cout this dot array length, that's fine. This is totally fine. But if you try to change it, that's bad. So the const makes it a read-only function. It protects the invoking object. Any questions on this const here? Or this const? Okay, so yeah, what does the const keyword stand for? It stands for constant. What does it mean to label a variable as const, and why would you do that? Labeling a variable as const protects it from some sort of change. For non-pointers, it's a very explicit how to protect it from change. But for pointers, depending on the location, it protects it from different levels of changing, different types of change, but const always protects change, stops some sort of change. Then what does it mean to return a const type from a function, and why would you do that? So that is protecting the return type from being changed. So let's go here. So if we did const int star foo, and then we did int star point, the new int 1, and then returned point. I'm gonna get rid of all this now. So here, if we did int star a equals foo, can't do that because it's saying a value of constant cannot be initialized to an entity of int. So now we have to make it const. So this return type has to match this one in this case. So that now protects the returned object the same way from all the other ones. So in that case, it's the first one that protects it from, you can't, it's 10, it's not that one, it's the other one. No, it is, yeah, okay, sorry, there we go. So that makes it so you can't change this value, so that protects it there. That's what that const keyword does there. I think if we made it, like I said, I think this is redundant. I think we did const int a point equals 1 point. You can do that, like that's legal. So yeah, without pointers, it's a little redundant because you can just do this. But with pointers, it does add that actual level of security. And then another thing, the final little bit is that also, I think this is just like a little stipulation with if returning by pointer and returning by reference. So if you return a pointer or you return a reference, both of those are faster. It's just a faster way to return information because again, it's not dealing with copying information anymore. It's dealing with the memory address. So even though this writes, so like here, you don't have to do anything with pointers, but it still returns that, but it is technically faster. Just a little bit. So when you deal with const and you deal with pointers, when you deal with const, it's protecting the information. When you deal with pointers and references, it's making stuff faster. Okay, so yeah, now we covered return const, create const member function. Why would you do that? Yes, we taught that protects this keyword, makes it read only. Okay, any questions about the study guide? Okay, if there's no more questions, we are done for today. That's all I have for you. Like I said, there's no lab this week, just the quiz. If you have any questions for the quiz, feel free to DM me. But with that, we are done. I'll stop my share. Have a wonderful day, guys. I'm proud of you for getting up at 8:30. Everyone's gone. All right, stop recording.